I'm Jules Murzeva. In this presentation, I will be talking about how simulations can create engaging students who can apply mathematical concepts into everyday life. Have you ever taught a class in which students get bored and unmotivated? I have. I teach pre-calculus to juniors and seniors. My students find pre-calculus class concepts hard to learn that doesn't really used or applied in their lives. They have hard time finding or constructing a valid and reliable purpose for learning pre-calculus except in passing a class with a decent grade. Need a way to spice up teaching and increasing student participation, motivation, and interest? If yes, then educators need to incorporate new media into their teaching. Simulations are easy to use, user-friendly tools that enables real-life applications of mathematical concepts. Simulations have the ability to make invisible visible, dynamic, and highly interactive. They provide multiple representations. They allow multiple safe trials and rapid inquiry, tools to make learning fun and relevant, and these are powerful tools enabling crafting and delivering high-quality lessons. What are the high-quality lessons? High-quality lessons invite students into purposeful interaction with the content through experience of real-world examples by allowing them to understand through conjecture, investigation, theorizing, and application. They provide multiple pathways to engage and develop conceptual connections among related phenomena and representations. High-quality lessons can be created through implementing problem-based learning through simulations. It will enable learning and practicing 21st century skills such as being a great problem solver and a critical thinker. Jonas has stated that problem-based learning includes problem-focused, student-centered, self-directed, and self-reflected activities. It makes higher and more applicable math concepts easy to learn. When really deep understanding and learning occur, when students are engaged in problem-solving learning with hands-on activities through simulations, they are engaged in deep learning that empowers understanding. Deep learning enables retaining knowledge in long-term memory for a longer time. Surface learning, like solving routine math exercise problems, doesn't really help students to fully comprehend and understand the math concept. The simulation example that I want to share and demonstrate is called Gizmos. It's an exceptional site that has simulations for science and math for grades 3 through 12. The best feature about the site is that you get activities specific to state standards or Common Core, and it comes complete with student worksheet and answer sheet. I want to share how Gizmo Simulation can help students better understand the concepts such as vector and projectile motion. Students will use simulation to visualize how trajectories of golf balls, cannonballs, satellites, and any object moving through space are affected by launch angle, initial velocity, gravity, and air resistance. In the golf range Gizmo, as students strive for a hole in one, they can select the launch angle and initial velocity, eliminate air resistance, and even alter the strength of the gravity. A lesson with Gizmo simulation usually starts with a motivational question to spark students' attention and curiosity. Question can be as simple as, should you hit a line drive low to the ground, or a shot with a very high angle if you are in a contest to see who can drive a golf ball the farthest. Students need to come up with a hypothesis to that question. To prove or disprove their hypothesis, students will run some experiments on Gizmo simulation. They can observe different changes by increasing or decreasing angle, speed, atmospheric pressure, and gravity. They can extend their thinking by discussing how the same experiment would occur on a different planet, such as Moon. You can see from an outline of the Gizmo activity and from demonstration, students will be engaged in higher order critical thinking by gradually elevating their thinking process according to the Bloom's taxonomy, starting from simple stage as remembering and going to evaluation and creating stage. These are my sources referenced in this presentation. Thank you for your attention.